Welcome to one more video on relative extrema and applications of derivatives for finding relative extrema. This example, I will see how to find um, extrema for the given function using the first derivative test. I will just list so here is the solution. And let's just, before the beginning, write out the steps. So the first step is to find f prime. Second is to find candidates by solving f prime equals 0. Third one is to determine sign of the first derivative. Fourth is then to conclude where relative extrema are and what are they. So are they minimum or maximum? So let us do the first step. F prime of x will be 2x cubed is 9x squared minus 60x prime, which is then 6x minus 18x, 6x squared minus 60. So that's the first step. Second step, weight the first derivative to 0, so 6x squared minus 18x minus 60 equals 0. We can simplify this, we can divide by 0. We can divide by 6 here. Divide by 6 squared minus 3x minus 10 equals 0. We can try to solve this. X1 is 2, x2 is minus 5. Therefore, we can factorize the first derivative as x minus sorry, it is minus 2 and 5. It's minus 2 and 5. So minus 2 and 5. So that is plus and x minus. Okay. So that's step 2. Step 3 is to find the sign of x. So in this case, we can go with the real axis. This is here 0. We place where the zeros are, so that's minus 2, and here is 5. And we put like vertical just lines in there, so we have the regions. And we write here x plus 2, x minus 5. Also here x plus 2, x minus 5. And here again x plus 2, x minus 5. So that's the derivative. And we will see where the function is increasing or decreasing. So now here. So now that we have found the derivative and we have found the zeros, we want to check the sign of the derivative. and to see where the sign changes, and that will help us identify relative minima and relative maxima. So here, for example, we can take minus 4 plus 2 and minus 4 minus 5, which is equal to, this is minus 2 times minus 9, it's 18. So here the derivative is positive. Then here changes the sign, it's negative, and after the 0, it becomes again positive. So when the derivative is positive, then of course the function is increasing, then it is decreasing, and then it is again increasing. This means that at 2 we have local maximum, at negative 2 it's local maximum, and at 5 it is local minimum. So we can write the following, let's say on 4, from minus infinity to minus 2, f is increasing. Then from between minus 2 and minus 5, f is decreasing. And from, here is 5. And from 5 to plus infinity, f is again increasing. And at x equals negative 2, f has relative maximum, and at x equals 5, f has relative minimum. So, and we can even go further. We can find the coordinates. How do we find coordinates? That will be, so relative maximum will be minus 2 f of minus 2. F of minus 2, not f prime. And relative minimum will be then 5 f of 5. So what is our f? It is 2x cubed minus 9x squared minus 60x. Now, as a task, just for you, you can find these points and also check them with any graphing software that they are correct. So this is the example 1 of how to find relative extrema of the function. Crucial here are these steps. And that's basically it. Okay, and see you in next video where we will see more examples. Okay. Now we are going to solve one more example, and here are the steps. So first we find f prime of x, that will be e to the power x cubed plus x squared plus 1, and then the derivative, so times the derivative of this. That is ex cubed plus x squared plus 1, 3x squared plus 2x. We can simplify further this derivative, so that is the first part stays the same, but here we can factor out x, and in the brackets is 3x plus 2. Second step is to find the zeros of the derivative, so f prime of x equals 0, and that means, so e to the power anything is always different from 0. So e 3x cubed plus x squared plus 1. This is always different from 0. So this here is always different from 0. Therefore, we must solve x 3x plus 2 equals 0. This gives us two solutions. So x equals 0 and 3x plus 2 equals 0, or not or, that means so x equals negative 2 over 3. Third step, we need to see the sign of the first derivative. So we put 0, we put negative 2 over 3 here, straight line here, and we take negative, so x times 3x plus 2. What is with the sign? We have negative 2 over 3 and 0. So let's take here negative 1. So we have negative 1 times 3 times negative 1 plus 2. That is greater than 0, so it's positive. And then here is negative, and here is positive. What does that tell us about the function? So the function is up to negative 2 over 3 increasing, then it is decreasing, and then again increasing. So that means that at negative 2 over 3 there is relative maximum, and at 0 there is relative minimum. So then we can also say from negative infinity to negative 2 over 3, f is increasing. Between negative 2 over 3 and 0, f is decreasing. And from 0 to infinity, f is again increasing. So we have found the points where it has relative maximum and relative minimum. And so here means and the intervals of increase and decrease. Thank you.